In this video, we will discuss about the chapter number 7, Electrochemistry. Chapter number 7, Electrochemistry. So, let's start introduction. In electrochemistry, we study the chemical changes which takes place uh, when electric current is passed through a particular type of material. We also study those chemical reactions which produce electric current. Electrical, Electrochemistry deals with the interconversion of electrical energy and chemical energy. The applications of electrochemistry are widespread. So, electrochemistry, we can say that we study about the chemical changes which takes place when electric current is passed through a particular type of material. तो ये कह रहे हैं कि जब हम इलेक्ट्रोकेमिस्ट्री में हम क्या पढ़ेंगे, इलेक्ट्रोकेमिस्ट्री में हम वो चीज़ पढ़ेंगे यानी जब हम करंट को पास करते हैं किसी मटेरियल में से तो उसके अंदर जो केमिकल चेंजेस वाक़या हो जाती है उसको हम कहते हैं इलेक्ट्रोकेमिस्ट्री. So we also study those chemical changes which produces electric current. So electrochemistry deals with the interconversion of electrical energy and chemical energy. इलेक्ट्रोकेमिस्ट्री जो है ये हमें बताता है कि इलेक्ट्रिकल एनर्जी को हम केमिकल एनर्जी को में कैसे कन्वर्ट करेंगे, इस हवाले से हमें बताते हैं या जो है केमिकल एनर्जी को इलेक्ट्रिकल एनर्जी में कैसे कन्वर्ट करेंगे. तो द एप्लीकेशन ऑफ इलेक्ट्रोकेमिस्ट्री, so you can say that application of electrochemistry are widespread. तो इलेक्ट्रोकेमिस्ट्री की बहुत सारे फायदे. So what is common in rusting of iron, combustion of fuel and food metabolism in human and animal bodies. All these processes involve oxidation, reduction, reaction. These reactions involve transfer of electrons. In previous grades, you have learned about the chemical reactions. In this unit, you will learn about oxidation, reduction, reaction. So, ये बता रहे कि जब रस्टिंग ऑफ आयरन, जब लोहे को जंग लगता है तो कंबशन ऑफ फ्यूल यानी फ्यूल की जब कंबशन होती है, जिस तरह पेट्रोल से गाड़ी या डीजल से गाड़ी चलती है तो इंजन के अंदर जो पेट्रोल की कंबशन होती है या डीजल इंजन या पेट्रोल इंजन के अंदर जो पेट्रोल या डीजल की कंजम्पशन होती है, या इसी तरह जो फूड मेटाबॉलिज्म जो हम खुराक खाते हैं उसकी जो मेटाबॉलिज्म होती है इंसान के अंदर और बाकी जो एनिमल्स है उनकी बॉडीज के अंदर, तो ये सारे जो प्रोसेसेस है, ऑल दिस प्रोसेसेस इन्वॉल्व ऑक्सीडेशन रिडक्शन रिएक्शन. तो ये सारे जो प्रोसेस होते हैं, मराहल होते हैं, इसमें ऑक्सीडेशन रिडक्शन इन्वॉल्व होता है. यानी ये ऑक्सीडेशन रिडक्शन रिएक्शंस के ज़रिए से हो रहे होते हैं. पहले जो ग्रेड्स थे उसमें हमने कह रहे हैं कि हमने केमिकल रिएक्शंस के बारे में डिस्कस किया और इस चैप्टर में हम ऑक्सीडेशन रिएक्शन के बारे में डिस्कस करेंगे. ऑक्सीडेशन रिडक्शन रिएक्शन के बारे में हम डिस्कस करेंगे. सो you can say you will also learn you will also learn about that how electrical energy is converted into chemical energy and chemical energy into electrical energy. तो इसमें हम ये पढ़ेंगे कि हम electrical एनर्जी को कैसे केमिकल एनर्जी में कन्वर्ट करेंगे या केमिकल एनर्जी को कैसे इलेक्ट्रिकल एनर्जी में कन्वर्ट करेंगे. So, oxidation and reduction. What is oxidation and what is reduction? Electrons are lost in oxidation and gained in reduction. Therefore, when oxidations occur during a chemical reaction, reduction must occur simultaneously. The number of electrons lost in oxidation must equal to the number of electrons gained in reduction. This name is often shortened to redox reaction. So, ये बता रहे कि जो ऑक्सीडेशन रिडक्शन के हवाले से कि ये क्या चीज़ है. तो इलेक्ट्रॉन्स ऑक्सीडेशन के दौरान इलेक्ट्रॉन की लास्ट होती है, यानी इलेक्ट्रॉन ज़ाया हो जाते हैं, इलेक्ट्रॉन चले जाते हैं, और रिडक्शन के दौरान गेन ऑफ इलेक्ट्रॉन होता है, गेन इन रिडक्शंस. तो रिडक्शंस के दौरान इलेक्ट्रॉन गेन होता है, जबकि ऑक्सीडेशन के दौरान इलेक्ट्रॉन को लॉस्ट होता है. Therefore, इसलिए when oxidation occur, जब ऑक्सीडेशन होती है ड्यूरिंग केमिकल रिएक्शंस, केमिकल रिएक्शन हो रहा है, तो अगर उस दौरान जो है जब ऑक्सीडेशन होती है तो रिडक्शन मस्ट अकर, रिडक्शन भी साथ साथ हो रही होती है साइमल्टेनियसली. So the number of electrons lost in oxidations must equal to the number of electrons gained in reduction. नंबर ऑफ इलेक्ट्रॉन जो लॉस्ट हो जाते हैं ऑक्सीडेशन के दौरान वो लाजमी बराबर होंगे जो नंबर ऑफ इलेक्ट्रॉन्स गेन इन रिडक्शन. यानी एक एटम अगर इलेक्ट्रॉन लॉस कर रहा है, मिसाल के तौर पर एक इलेक्ट्रॉन लॉस कर रहा है, तो दूसरा उस एक जो इलेक्ट्रॉन होगा उसको गेन करेगा. यानी एक की ऑक्सीडेशन हो रही है और दूसरे की रिडक्शन हो रही है, यानी एक इलेक्ट्रॉन लॉस कर रहा है और दूसरा इलेक्ट्रॉन हासिल कर रहा है. तो ये दोनों रिएक्शन साथ साथ होते हैं. नाउ ऑक्सीडेशन क्या चीज़ है? फर्स्ट ए, the addition of oxygen to a substance is called oxidation. For example, carbon is oxidized to CO2, which involves the addition of oxygen. The reaction is C plus O2 equal to, this gives CO2. So, you say addition of oxygen किसी सब्सटेंस में जब ऑक्सीजन ऐड होती है तो उसको हम ऑक्सीडेशन कहते हैं. तो उसको हम क्या कहते हैं? ऑक्सीडेशन. मिसाल के तौर पर कार्बन को हम CO2 में जब कन्वर्ट करते तो उसकी ऑक्सीडेशन हो रही होती है, तो उसमें एडिशन ऑफ ऑक्सीजन हो रहा होता है. ये कार्बन है हमारे पास, इसमें एक ऑक्सीजन, दो ऑक्सीजन जो है वो ऐड हो रहे हैं, तो ये रिएक्शन हो रहा है. तो आगे हमारे पास प्रोडक्ट में CO2 बनता है. तो यानी ये जो रिएक्शन है इसमें ऑक्सीजन की एडिशन हो रही होती है, तो इसको हम कहते हैं ऑक्सीडेशन. यानी द एडिशन ऑफ ऑक्सीजन टू सब्सटेंस. वी आर गोइंग टू एड ऑक्सीजन इन कार्बन एटम, so this is called oxidation of carbon. And you can say the removal of hydrogen or the other two positive elements from substance is called oxidation. For example, ammonia oxidized to nitrogen by losing hydrogen. This is the reaction. So you can say that removal of हाइड्रोजन, जब हाइड्रोजन की जो रिमूवल है किसी कंपाउंड से, उसको भी हम ऑक्सीडेशन कहेंगे। मिसाल के तौर पर अमोनिया है, तो अमोनिया को अगर ये जो क्लोरीन के साथ रिएक्शन करता है तो नाइट्रोजन बनता है और HCl बनता है। तो यहाँ पर अमोनिया से हाइड्रोजन को रिमूव हो रहा है, तो इसको हम कहते हैं ऑक्सीडेशन। सो यू कैन से that when ammonia reacts with chlorine, so 2 moles of ammonia reacts with 3 moles of chlorine, so it gives a product on nitrogen and HCl. So in this case, hydrogen is removed from ammonia. So you can say hydrogen is uh, removed from the ammonia, which gives a product of this one. So this is called oxidation. Now third one, the removal of electrons. You can say the removal of electrons from a substance is called oxidation. For example, when Fe plus 2 losses electron and oxidizes to Fe plus 3. So in this case, we can say that iron is oxidized by losing electron. So we can say that here iron is in plus, you can say that iron is in plus 2 oxidation state in this case, while it is converted into plus 3 oxidation state. So it seems that the oxidation state of iron is increased from plus 2, you can say, from plus 2 to plus 3. So by loss of 1 electron. So this is the loss of 1 electron. So this is called oxidation. So iron has lost 1 electron. So in this case, iron is converted from plus 2 oxidation state into plus 3 oxidation state by losing 1 electron. So this is called oxidation. Now let's come towards reduction. The removal of oxygens from a substance is called reduction. For example, HU is reduced to Hg on heating. I can say reduction is the removal of oxygens, such as in this case Hu is converted into Hg plus O2. So in this case, oxygen is removed on heating. So due to which reduction takes place. So the removal of oxygen, you can say this is called reduction. The addition of hydrogen to a substance is called reduction. For example, hydrogen is reduced to ammonia. The addition of hydrogen, so you can say the addition of hydrogen. So this is the addition of hydrogen to nitrogen, which gives ammonia. So this is also called reduction. The addition of hydrogen in a substance is called reduction. The addition of electrons to a substance is also called reduction. For example, Sn plus 4 gains 2 electrons and reduces to Sn plus 2. So this is the reaction. In the chemical reactions, Sn plus 4 is converted into Sn plus 2. So you can say Sn is converted from plus 4 oxidation state plus 4. So we can say Question is reduce from +4 to +4 +2 oxidation state. So this is +4 oxidation state and this is +2. So Sn is reduced from +4 into +2 oxidation state by gaining of 2 electrons. So this is called reduction. Consider the reaction between sodium and chlorine. The reaction involves the transfer of electrons from sodium atom to chlorine atom. Sodium atom loses 1 electron and is said to be oxidized to sodium plus sodium ion, while chlorine atom gains 1 electron and is reduced to chloride ion. So those reactions in which gain or loss of electrons takes place simultaneously is called oxidation, reduction, reaction, or you can say redox reactions. In this case, sodium reacts with chlorine to form sodium chloride. So in these reactions, gain and loss of electrons takes place because sodium lost an electron to chlorine atom, which gives sodium chloride. So due to oxidation, reaction, you can say redox reaction, sodium chloride is reduced. Next one is oxidation states and rules for assigning oxidation states. Number 1, oxidation states or oxidation number. It is the apparent charges, positive or negative, on an atom of an element in a molecule or an ion. Unlike ionic charges, oxidation numbers don't have exact physical meanings. In fact, in some cases, they are quite arbitrary. However, oxidation numbers are useful in naming compounds. So in writing formula and embracing chemical equations, the color of solution changes with the change of oxidation state. So we can say, in this case, color change of chromium solutions, the change of oxidation state. So chromium in +2 form is in blue color, while chromium in +3 oxidation state is in green form, while chromium in +6 oxidation state is in orange form. So you can say this is the color of chromium in different oxidation states. We can say +2 is below, and +3 that is green. So this one is green, and +6 oxidation state is orange. So this is the different colors, different oxidation states of chromium. So rules for assigning oxidation number. This is the rules for assigning oxidation number. The oxidation number of all elements in the free state is 0. For example, the oxidation number of H2, Cl2, Na, etc. is 0. तो ये कह रहे हैं कि जो ऑक्सीडेशन नंबर होते हैं, जो जितने भी एलिमेंट्स हैं, उनकी जो ऑक्सीडेशन नंबर होते हैं वो फ्री स्टेट में 0 होते हैं. मिसाल के तौर पर ऑक्सीडेशन नंबर जो हाइड्रोजन का है, क्लोरीन का है और सोडियम का है, ये इसका ऑक्सीडेशन नंबर 0 होता है. ये फ्री स्टेट में मौजूद है. Similarly, the oxidation number of a simple ion is the same as the charge on it. For example, the oxidation number of Na plus, Ca plus 2, Al plus 3 and Br minus are +1, +2, +3, -1 respectively. कहते हैं कि जो ऑक्सीडेशन नंबर होते हैं सिंपल आयन का वो सेम होता है, यानी जितना उसके ऊपर चार्ज होगा उतना उसका ऑक्सीडेशन नंबर होगा। मिसाल के तौर पर सोडियम प्लस जो है इसके ऊपर +1 है, तो इसका जो ऑक्सीडेशन नंबर है ये भी +1 है। तो सिमिलरली जो कैल्शियम है, कैल्शियम का जो ऑक्सीडेशन नंबर है वो +2 है, क्योंकि उसके ऊपर चार्ज भी +2 है। एल्यूमिनियम के ऊपर चार्ज +3 है, तो इसका ऑक्सीडेशन नंबर भी +3 है। ब्रोमीन ब्रोमाइड के ऊपर माइनस चार्ज है, तो इसका ऑक्सीडेशन नंबर भी -1 है। So similarly, the oxidation number of hydrogen in its compound is +1, except in the case of any metal hydrides, which is -1, such as Na plus 1H -1. again oxidation number हाइड्रोजन का जो होता है कंपाउंड में वो +1 होता है, यानी ऑक्सीडेशन हाइड्रोजन का ऑक्सीडेशन नंबर है वो +1 होता है, सिवाय मेटल हाइड्राइड्स की जिसमें -1 होता है। इस तरह इसमें हाइड्रोजन का -1 है और सोडियम का +1 है, यानी NaH मेटल हाइड्राइड, इसमें हाइड्रोजन का रिलेशन क्या है, इस नंबर क्या है -1 और सोडियम का है +1। So the oxidation number of oxygen in its compound is -2, except in the case of peroxide where it is -1, for example H2O2, and in the case of OF2 it is +2। ऑक्सीडेशन नंबर ऑक्सीजन का कंपाउंड में -2 होता है, जितने भी कंपाउंड है उसमें जो ऑक्सीजन का जो ऑक्सीडेशन नंबर है वो -2 होता है, एक्सेप्ट सिवाय उस सूरत में जिसमें वो पेरोक्साइड फॉर्म मौजूद हो, उसमें क्या होता है माइनस होता है ऑक्सीडेशन स्टेट। फॉर एग्जांपल H2O2 इसमें, यानी H2O2 जो है H2O2, तो यहाँ पर हाइड्रोजन है, हाइड्रोजन का +2 जाएगा, यहाँ पे -2, तो यहाँ पे जो ऑक्सीजन का यू कैन से ऑक्सीजन का जो ऑक्सीडेशन स्टेट है नॉर्मल कंडीशन में वो -2 में होता है, लेकिन H2O2 फॉर्म में जो ऑक्सीजन का ऑक्सीडेशन स्टेट है वो -1 में होता है। So because it is in the form of H2O2, because H is in the +1 form, so 2H will be equal to +2. So in order to make it neutral, it is necessary for oxygen to have oxidation number -1. So in this case, oxygen have oxidation number of -1. Similarly, the oxidation number of each element of group first, second and third is +1, +2, +3 respectively. ऑक्सीडेशन नंबर जो एलिमेंट्स का होता है ग्रुप फर्स्ट, सेकंड एंड थर्ड में +1, +2, +3 होता है। The oxidation number of each element of group 7 halogen in their binary compound is -1। तो ऑक्सीडेशन जो नंबर है वो ग्रुप 7 के जो एलिमेंट है जो हेलोजन है उनका होता है कंपाउंड इज -1 होता है। हेलोजन के जो कंपाउंड है उनका जो जितने भी एलिमेंट्स हैं उनका ऑक्सीडेशन नंबर होता है -1। So you can say that number 7, the neutral molecule. In neutral molecule, the algebraic sum of the oxidation numbers of all the elements is 0. For example, H2SO4. न्यूट्रल कंपाउंड जितने भी हैं उसमें जो सम ऑफ ऑक्सीडेशन नंबर होता है वो 0 के बराबर होते हैं। फॉर एग्जांपल इन केस ऑफ सल्फ्यूरिक एसिड, we can say that is 0. So how it becomes 0? We can say that the furic acid has the formula H2S4. So we have 2 hydrogen. This is the 2 hydrogen, and we have 1 sulfur. So this is the 1 sulfur, and 4 oxygens, and this is the 4 oxygen. So we can say that 2 hydrogens and 2 hydrogen having +1 charge. So we can say that that is 2 hydrogen. So in this case, we are going to determine the oxidation state of sulfur. So we have, this is the 2 hydrogen, and sulfur is as such. Sulfur, well, that of oxygen, 4 oxygens having -2 charge each, that will be equal to -8. So that will be equal to 0. So you can say that 2 plus S minus 8 plus S minus 8 is equal to 0. You can say S minus 8 plus 2 is equal to 0. S minus 6 is equal to 0. So we have S is equal to 6. So sulfur has oxidation number of +6. So when you put this, the oxidation state of sulfur +6 on, we will get the algebraic sum of the oxidation number of all the elements 0. So in this case we have noted this one, and finally we get 0. So in other words, we can say that we have 2 hydrogen, so we having +1 charge, this will be equal to +2. And if we add oxidation state of sulfur +6, while that of oxygen has -2 charge, so there are 4 oxygens, we can say that oxygen will be -8. So in this case we can say +2 +6 -8. So that will be equal to +2 +6 +8 and -8. That will be equal to 0. Therefore it says that a neutral molecule, this is a neutral molecule having no charge. So a neutral molecule, the algebraic sum of the oxidation number of all the elements such as hydrogen, sulfur and oxygens is 0. That is 0. So this is the example of sulfuric acid in which the oxidation state of all the elements equal to 0. Now, number 8. In ions, the algebraic sum of oxidation numbers equal to the charge and the ion. For example, MnO4. In case of MnO4, we see MnO4 has -1 charge. So Mn, there are 4 oxygens, so Mn plus 4O, that will be equal to -1. So Mn plus 4 minus 2 is equal to -1, and Mn plus 8 is equal to -1, and Mn minus 1 plus 8, that will be equal to 7. So manganese has +7 oxidation state. You can say that in case of MnO4, it has -1 charge. So we know that if we're going to determine the charged manganese, we know that there are 4 oxygen atoms, 4 oxygens, and having charge -1, so that will be equal to -1. So manganese plus 4, -2 is the oxidation state of oxygen, so that will be equal to -1. So Mn, this is 4 to 8, so you can say that, so this is the minus, not plus. So if here, so when this will move, this here, it will get +1, so that will be equal to +7, such as we can say Mn 4 -1, so you can say Mn plus 4 is equal to -1, Mn plus 4 -2 equal to -1, so Mn -8 equal to -1. You can say Mn is equal to +8 -1, that will be equal to 7. This is +7. Mn is in +7 oxidation state. So therefore it says that in Heinz, the algebraic sum of oxidation numbers equal to the charge on the ion. So next one is, in any substance, the more electronegative atom has the negative oxidation number. So in any substance, you can say the more electronegative atom has the negative oxidation number. So we can say if we have a substance, then in this case, the more electronegative atom will have always negative oxidation number, while the same elements may show different oxidation number in different compounds, such as CO and CO2, carbon monoxide and carbon dioxide. So you can say case of CO, case of CO2. So in case of you can say CO, we know that oxygen has -2 oxidation state. So in order to make it neutral, it is necessary carbon will have +2 oxidation state, and that will be equal to 0. Similarly, in case of carbon dioxide, you can say that oxygen has -2, so that will be equal to -4. So in this case, carbon will be in the form of +4 oxidation state, and its net will be equal to 0. So the same element may show different oxidation numbers in different compounds. So in this case, carbon show different oxidation number, and CO2 it show +4 oxidation number, while in case of CO it shows +2 oxidation number. Now, this is the example we given. Determine the oxidation number of phosphorus and chlorine in phosphorus pentachloride, PCl5. So solution, in this compound, the oxidation number of each chlorine atom is -1. So in case of PCl5, phosphorus pentachloride. So we know that in this case, chlorine has -1 oxidation number. So to make total of all oxidation numbers for PCl5 equal to 0, the phosphorus must have an oxidation number of +5. To do this calculation systematically, that's X equal to the oxidation number of phosphorus in PCl5. So here we see that if X is the oxidation number of phosphorus, and we know that there are 5 chlorine atoms, and each chlorine atom has -1 oxidation number. So, and we are going to make it 0, the net charge. So this is X, this is the oxidation number of phosphorus, and +5 is the number of chlorine atoms, where -1 is the oxidation number of each chlorine atom. So 0 is the charge on the molecule, which will be equal to 0. So we can say that X is a +5 minus 1 is equal to -5. So X minus 5 is equal to 0, and X is equal to +5. So in this case, you can say that phosphorus will have oxidations a number of +5. So thus the oxidation number of phosphorus is 5, and the chlorine is -1. So this is the second example. What is the oxidation number of nitrogen in the nitrite ion NO2? So the oxidation number of oxygen in most surface compound is -2. So here we are going to determine the oxidation number of nitrogen in case of Na2. In case of NO2, we are going to determine the oxidation state of nitrogen. So we know that if X is the oxidation number of nitrogen, and we know that there are 2 oxygen atoms, and each oxygen has -2 charge, so and that will be equal to the net charge -1. So this will be equal to X. So X, it will be -4. So X minus 4 -1. X is equal to -1 plus 4. X is equal to +3. So the nitrogen in nitrite is in +3 oxidation state. So we can say that in this case, for example N, there are 2 oxygens, and each oxygen having -2 charge. The net charge is equal to -1. So N -4 is equal to -1. You can say N is equal to +4 -1. And that will be equal to 3. So N is equal to +3. Nitrogen has oxidation number +3 in nitrite. So here we are given that most obvious characteristic chemical property of transition metal is the occurrence of variable oxidation state. Most transition elements have variable oxidation states in their compounds. For example, iron exists most commonly in Fe2, Fe3 oxidation states. Copper have 3 oxidation states: Cu1, Cu2, and Cu3. Manganese has 6 different oxidation states, which is Mn+2, +3, +4, can say +5, +6, and +7. Next one is oxidizing and reducing agents. So what is oxidizing agent? An oxidizing agent is a species that oxidizes a substance and itself get reduced. ऑक्सीडाइजिंग एजेंट जो है ना वो स्पीशी होते हैं जो दूसरे सब्सटेंस को ऑक्सीडाइज करता है यानी उससे इलेक्ट्रॉन लेता है और खुद रिड्यूस हो जाता है जब कोई एटम जैसे दूसरे एटम से इलेक्ट्रॉन लेता है तो वो खुद रिड्यूस हो जाता है जबकि दूसरा एटम जो है वो ऑक्सीडाइज हो जाता है तो इसको कहते हैं ऑक्सीडाइजिंग एजेंट। मिसाल के तौर पर KMnO4 potassium dichromate, K2Cl27, HNO3 nitric acid, and Cl2 chlorine. So these are the oxidizing agents. So according to classical concepts, the oxidizing agent may be the donor of oxygen to a substance, the acceptor of hydrogen from a substance, the acceptor of an electron from a substance. Similarly, the oxidation number of an oxidizing agent is decreased during redox reaction. So ये कह रहे हैं कि जो ऑक्सीडाइजिंग एजेंट होता है वो यानी ऑक्सीजन को डोनेट करता है किसी सब्सटेंस को या जो ऑक्सीडाइजिंग एजेंट होते हैं वो हाइड्रोजन को एक्सेप्ट करता है किसी सब्सटेंस से या जो एक्सेप्टर ऑफ इलेक्ट्रॉन होते हैं या जो इसकी जो ऑक्सीडाइजिंग एजेंट की जो ऑक्सीडेशन नंबर होता है वो कम होता है रिडक्स रिएक्शन के दौरान क्योंकि वो इलेक्ट्रॉन गेन करता है जिसकी वजह से उसकी रिडक्शन हो रही होती है तो जिसकी वजह से उसकी जो ऑक्सीडेशन नंबर है वो कम हो जाता है। मिसाल के तौर पर मैंगनीज है ये +7 फॉर्म में होता है जब ये 5 इलेक्ट्रॉन्स गेन करता है तो वो Mn+2 फॉर्म में चला जाता है। तो अब इसका मतलब है कि ये इसका जो ऑक्सीडेशन स्टेट है वो रिड्यूस हो गया फ्रॉम +7 to +2। सो देयरफॉर ये कह रहे हैं कि the oxidation state of an oxidizing agent decreased during a redox reaction। तो in this case to main Mn+7 that is the oxidizing agent। Consider this reaction in between, you can say, zinc and copper oxide. It produces zinc oxide and copper. So in this case, you can say that zinc reacts with copper oxide to form zinc oxide and copper. So in this case, we can say that copper oxide is converted into copper. So this is reduced. Copper is reduced. Copper oxide is reduced to copper, while zinc is oxidized to zinc oxide. Because copper oxide gives oxygen to zinc, which produces zinc oxide. In this case, copper oxide will be reduced to copper, and zinc is oxidized to zinc oxide. So we can say that oxidation number of copper in CO is +2. Oxidation number of copper is 0. So there is decrease in oxidation state of copper from +2 to 0. So CuO is oxidizing agent in the given reaction. So it says that in this case, it says copper oxide. So we know that oxidation state of oxygen is -2. So in order to get net charge 0, it is necessary that copper will have oxidation state +2. So copper is in +2 oxidation state in Cu. So in this case, copper is Cu in 0 oxidation state. So it means that copper is changed from +2 oxidation state to +0. So you can say that copper is changed from +2 to 0 oxidation state, which is reduced. Oxidation state of copper is reduced. So we can say that there is decrease in oxidation state of copper from +2 to 0. So copper oxide is oxidizing agent in a given reaction. Similarly, consider another example in which Sn plus 2 plus Cl2, which gives Sn plus 4 plus 2Cl minus. So in this case, in this reaction, oxidation number of chlorine is 0. Oxidation number of chloride is -1. So there is a decrease in oxidation number of chlorine from 0 to -1. So chlorine is an oxidizing agent in the given reaction. So you can say that we have first discussed about the oxidizing agent. So this is another example about oxidizing agent in a given reaction. In this case, oxidation state number of chlorine is 0. So in this case, oxidation number of chlorine is 0. So in this case, oxidation number of chlorine is -1. So chlorine is there is decrease in oxidation state of Cl2. So it is decreased from 0 to -1. From 0 to -1. So chlorine is an oxidizing agent in the given reaction. And next one is the reducing agent. The reducing agent is the species that reduces substance and itself gets oxidized. Reducing agent एक वो स्पीशीज है जो खुद ऑक्सीडाइज हो जाता है और दूसरे को रिड्यूस करता है. मिसाल के तौर पर यानी इसका मतलब ये कि जो रिड्यूसिंग एजेंट होता है वो अगर वो itself gets कैन से अगर itself ऑक्सीडाइज हो जाता है तो इसका मतलब ये कि वो इलेक्ट्रॉन लॉस करता है. एंड रिड्यूसेस सब्सटेंस यानी अगर किसी और को रिड्यूस करते हैं इसका मतलब उनको इलेक्ट्रॉन दे रहे हैं. फॉर एग्जांपल H2S, SO2, sodium, aluminium, magnesium, etc. According to classical concept, reducing agent may be the acceptor of oxygen from a substance, the donor of hydrogen to a substance, the donor of an electron to a substance. Similarly, the oxidation number of reducing agent is increased during a redox reaction. So, you can say that in case of reducing agent, the reducing agent itself oxidized and itself is reduced, and we can say it's itself is get oxidized. So why this occur? Because the reducing agent accept oxygen from a substance, while it gives hydrogen to substance. You can say, it gives electron to substance. So the oxidation number increases. So this is the example of bromine plus H2S, Br2 plus H2S, that gives HBr plus S. So this reaction, you can say that bromine is in zero oxidation state, while the product of bromine is get converted into zero oxidation state. So in this case, bromine is oxidized. Bromine is, you can say, reduced, while that of H2S is oxidized. So you can say that in this case, bromine is in zero oxidation state, and it is converted into HBr. This one. So oxidation number of sulfur in H2S is -2. So in this case, the oxidation number of sulfur is -2. The oxidation number of free sulfur is 0. This is a free sulfur, and the oxidation state of sulfur is 0. So there is increase in oxidation number of sulfur from -2 to 0. So H2S is a reducing agent. H2S is a reducing agent because sulfur oxidation state is reduced from -2 to 0. So it gets reduced. So H2S is, you can say that is a reducing agent. This is a table given about oxidizing agents and reducing agents. So bromine, you can say it's an oxidizing agent. Chlorine, concentrated sulfuric acid, nitric acid, oxygen, potassium permanganate, potassium dichromate. These are oxidizing agents, while carbon monoxide, these are all reducing agents. Hydrogen sulfide, metals, potassium iodide, sulfur dioxide. So these are all reducing agents, and these are all oxidizing agents. Next one is oxidation and reduction reactions. Those chemical reactions in which the oxidation reaction, you can say loss or gain of electron, takes place simultaneously are called oxidation reduction or redox reaction. For example, copper sulfate plus Zn, it gives zinc ZnSO4 plus Cu. So the overall equation is Cu plus 2 plus zinc, and it gives Zn plus 2 and Cu. So we can say that in this case, copper is in +2 oxidation state, and here copper is in 0 oxidation state. So the oxidation state of copper decreases, you can say, from +2 to 0. From +2 to 0. So it decreases in oxidation state while in case of zinc has oxidation state 0 and it is converted into +2 oxidation state. So the oxidation state of zinc increases from 0 to +2. So we can say in this case copper is reduced. Copper is reduced while that of zinc is oxidized. So in this case we can say that copper is an oxidizing agent while that of zinc is a reducing agent. So we see that copper is an oxidizing agent and so it accepts electron from zinc, so it gets reduced from +2 to 0 oxidation state while it oxidizes the zinc. So the zinc is oxidized from 0 to +2 oxidation state. So we can say that copper is an oxidizing agent while zinc is a reducing agent in this case. Copper is oxidizing agent while that of zinc is a reducing agent. Similarly, you can say that reaction between sodium and iodine gives to an Na plus iodide. So the reaction can be written in the form of two half reactions. So sodium gives +1 +2. In this case, there is 2 sodium. So 2 sodium can lose 2 electrons. So you can say that this is oxidation because loss of electron is called oxidation. While in case of iodide, say that it gains 2 electrons because there are 2 iodine atoms. So it produces iodide. So this is the reduction because gain of electron is called reduction. Now, in the first half reaction, loss of electron takes place. The reaction is called oxidation reaction. In the second half reaction, gain of electron takes place. So this reaction is called reduction reaction. Let's say this is the redox reactions. Redox reaction involve both electrons, you can say oxygen, nitrogen, and oxidation states. So this is the chart about the loss of or gain of electrons. I can say about redox reaction. So and you can say the chart of redox reaction. So it shows that about redox reaction, we can say that reduction will take place if an atom gains, you can say, gains electrons, while oxidation will take place if an atom loses electrons. Similarly, if an atom, you can say in redox reaction, loses oxygen, so reduction will take place, while if it gains oxygen, you can say oxidation will take place. Similarly, if an atom gain hydrogen, you can say reduction will take place, while if it loses hydrogen, oxidation will take place. Similarly, if there is a decrease in oxidation states, we can say that reduction will take place. Reduction occurs, while if there is increase in oxidation states, we can say that oxidation will take place. So when reduction takes place, what will happen? It means that it is called by the reducing agent. You know that reduction caused by the reducing agent, while the oxidation takes place due to oxidizing agent. So we can say, so these are the examples. Potassium dichromate, potassium permanganate. So you can say these are the KMnO4 and KMnO4, potassium dichromate. And this is equals potassium iodide, colorless brown. So here is the reducing agent. Example is hydrogen, carbon, and carbon monoxide. So you can say these are the example of reducing agents. So this is about the redox reaction. So in next video we will discuss about the electrochemical cell.